My name is Raj Mountain.
People
I'm
just
one of the
don't think,
savants here
focus on
a number of years.
that wall was not there at all. Where they are showing presentation.
Last night I was at a movie
Do you want to move it?
called, it's actually a movie on Ramanujam,
Let's go louder.
mathematician from India. And the Man Who Knew the Infinity, it's playing in Irvine Theatre. It's one of them, done very well. And his equations are used even today for investigating black holes. You know, we all come here every Sunday and listen to our Acharya, Swamiji, and Madhavanji. And then some of us have even attended a number of those sessions that they have done for a number of years. Swamiji has taught, especially last 2 years, with intensity, a group of individuals into deep philosophies, deep Vedantic philosophies. And prior to that, many of us old-timers, I would call myself, so we have learned about many Upanishads, and of course all of us have been learning about Bhagavad Gita as well. Now, as a part of imparting this knowledge, we said, okay, why don't we approach from a different angle, which is the scientific angle, and see if we can bring these two things together. So, in that effort, we have today in front of us Dr. Pankaj Joshi. And before I introduce him, I would like to take one moment and acknowledge the help that we received from Soneji. Soneji, for the last 30 years, has been a teacher of yoga and our philosophies to a number of people, and we recognize his service to our communities. Thank you, sir. It is him who has brought Dr. Pankaj Joshi for making this presentation to all of us. Dr. Pankaj Joshi is a senior professor of astronomy and astrophysics with the Tata Institute of Fundamental Research, Mumbai. He works in the fields of gravitation and cosmology and has published more than 150 technical papers, research papers, monographs, and books on this subject matter. He has held visiting faculty positions in several countries, doing research and lecturing on these topics, and he has won several awards as well as competitive fellowships to scientific academies. Professor Joshi has made fundamental contributions in black hole physics and gravitational theory. His extensive analysis of general relativistic gravitational collapse has been widely recognized as providing significant insights into the final fate of massive collapsing stars in the universe. Formation of space-time singularities, the black holes have that concept, and the cosmic censorship. He has contributed a large number of books and articles towards science outreach and has given a large number of public lectures. He comes to the United States to speak at many universities and research institutes. Of course, he's going from here to Harvard. That's what he just told me. He has a PhD in physics from Bhavnagar University in Gujarat, and presently and postdoctoral training in National Science Foundation Research Fellow, University of Pittsburgh, and he's a visiting fellow of Tata Institute of Fundamental Research in Bombay. He's recognized with many number of awards. He's a fellow of Indian National Science Academy. He's a fellow of the National Academy of Sciences in India. He's a fellow of Gujarat Society Gujarat Science Academy, Nuffield Foundation Fellowship. Number of these awards, close to 30 of them. In addition, his interests are in the area of gravitational theory and cosmology, quantum gravity, gravitational collapse, cosmic censorship, and black hole physics, space-time structure and the general theory of relativity, and relativistic astrophysics. Quantum side, he tries to somehow bring the quantum, which is very small and subtle, and tries to link that to macroscopic cosmos. And he'll describe that. It was very effective this morning, so I'd love to hear it again. And his recent book, The Story of Collapsing Stars, received rave reviews. And one such review is Oxford Press stated, the book journeys into one of the most fascinating intellectual adventures of recent decades. Today's topic for presentation is to discuss recent developments in modern cosmology and physics to show how the science and spirituality are one and united in their key purpose. The second point of understanding will be the importance of science and spirituality in a combined manner, as it is not only essential but is inevitable in the present day world where we have all this violence and incitement and we have a lot of problems going on. So he emphasizes on that. And third, and important to all of us, understanding the cosmos includes understanding the self. Also, since we ourselves are an integral part of the universe, the relationship between spirit and matter, the consciousness and the object field, that's what we learn in our Bhagavad Gita chapter 13 and everywhere else. Of course, he also promised to bring two movies into focus, which we have probably seen. One is called The Theory of Everything, and the second one is Interstellar movie. And you may want to touch upon that, we probably didn't have enough time. Hopefully we have enough time for him to complete his lecture and a few questions if possible towards the end. And Dr. Mahadevan, Acharya Mahadevan, he is a physicist himself. He will do the conclusion towards the end. Enjoy. There you go.
Thank you very much again to Sri Swamiji, Acharya Mahadevaji, Raj Mataji, and to the Chinmaya Institution. It's indeed a special privilege actually to be speaking second time in the same morning to all of you, because sometimes what happens is after you have given one lecture, people may say that that is enough. But now that we are here, it's again a fascinating opportunity to probe the cosmos, to discuss the issues which touch the basic inquiry that you see the human being has for millennia, so to say. As I was saying in the morning, actually, the modern physics is nothing else but the inquiry into the basic laws, the fundamental laws of nature. And as I stated, which I would like to restate. The word physics actually came from the Greek word physis, P-H-Y-S-I-S, which is the key element, the fundamental substance governing the universe, or at the root of all the phenomena that we observe in and out, day in and day out. And then the most important point, or the most important thing, is as you observe the universe, as you probe it, then you find a certain amount of symmetry and harmony within the universe. The universe is going according to certain definite fundamental laws. It's not an arbitrary happening. The sun rises, the moon comes, the tides happen, the eclipses take place. All these patterns take place one after the other in a systematic and very definite way. And the great miracle, if you say so, you see, Rajji referred to Ramanujam, the Indian mathematical prodigy. So the miraculous efficacy of mathematics in describing the universe. Why is it possible to describe the universe using mathematics? If you ask this question, so there lies a very fundamental technique, you see, that we have. The human beings have developed. What mathematicians do, and this is relating actually to what I am going to say a little later. We have been striving to achieve in modern physics a unification between the gravitation and the quantum, which is the unified field theory for all of the cosmos. Now, if you want such a unified field theory, then you see, when you deal with quantum and when you deal with the force of gravity, then you are definitely faced with a dilemma of who is the observer and what is the observed. And generally, we always make a separation between the observer and the observed. That is, you see, if I am standing here and you are listening to me, then our interaction is my speaking and your listening. But other than that, is there any other interaction between the observer and the observed? So this is a frontier field where actually modern physics and some of the ancient traditions actually are coming together. But anyway, what I was telling you earlier was how the modern mathematics has been so successful in probing or creating the laws of the universe. What mathematicians do is they make an axiom system. What is called an axiom system? Like, take the geometry of Euclid. Then he would say, what is a point? So point has no dimension but an existence. It has no length, it has no breadth, it has no width. Still, that abstraction is point. So you draw a circle. So how you explain this point? You draw a circle, it becomes a smaller, smaller, smaller. Okay, take this circle, it has certain radius or a certain diameters. Make it smaller, 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 smaller. And if you indefinitely continue this process, then that is the point, so to say. So that, what I mean to say is, it is an abstraction. It is not something actually existing, but you abstract the concept from what you already observe in the universe. That is, the earth is there, then a smaller planet, still a smaller planet, still a smaller planet. And then you take the indefinite limit of that process, then that is again a point. Then line. So it has a length, but it has no width. And then Euclid gave a certain system of axioms that given any 2 points, there is one and only one line connecting the two, and so on and so forth. But the important point is, having given these axioms, then he could develop the geometry, which is called Euclidean geometry, triangles and all those things. And the most interesting thing is, it is useful in describing the laws of nature. The reason is, you have made these abstractions from, the observed objects, and then you could work with them. You could do things, you could prove theorems with those things, and that helped you, again, in turn, to, predict more about the cosmos, about the universe. So, this unique faculty of abstraction is the most important part of the modern science. But let us go on with the slides. Next one. You see, we observe the universe with, our 5 senses. The touch, the smell, and then we, have, the sound and vision and all those things. But then the scientists, what they did was to supplement the senses with instruments, missions. And what you see on the screen here are the 2 telescopes which were built, in the early part of the 90s, the 19th century. That is, one on your left is a kind of, optical telescope. On the other side is, you see, a mirror-based telescope. They are so huge. Actually, you can see from the size of the, people, the scientists who are sitting there observing. The important point is that you are supplementing your observations, which are made with the help of senses. Your eyes will not be able to see, too far into the skies, but this telescopes will see far away in the cosmos. Next one. And when you are on Earth, you have, various obstructions, really, to observe the, objects far away in the universe. However, when you have, a telescope like this one, it's, out there in space, and such a space-based telescopes can, see much farther away. Next one. This is yet another kind of a telescope. It's, a radio telescope disc. Next one. And this is an X-ray telescope. You see, the X-rays coming from black holes, from singularities, from farthest of the objects in the cosmos. And those X-ray observations are made using the X-ray telescopes. This is one of the telescopes named after Professor Chandrasekhar, Subramaniam Chandrasekhar, a great astrophysicist. Next one. Now, on one hand, we see the cosmos at its widest of the scales, the very large scales in the universe. But on the other hand, you see also the universe in its tiniest of the, dimensions, atoms, or the, electrons and protons, and so on and so forth. And this is the Large Hadron Collider, one of those experiments which is based at CERN in Geneva. Next one. So, here is, you see, one of the most interesting phenomena. what they do in this Large Hadron Collider is they accelerate the particles like electrons, like protons. They accelerate them to very, very high velocities using the magnets which are placed. Actually, in the previous picture, this whole huge tube was there. So that tube is essentially, an alignment of magnets, basically. Those magnets, sort of accelerate the particles to a great degree. When an electron is there, when a proton is there, the proton is positively charged, and then magnets will accelerate them. It will go faster and faster and faster, and then what will happen eventually is that they collide with these particles. Now, there is something extremely interesting here, which is this. We have, you see, 3 regimes. One regime is the, human beings and our own scales, and then we make cars, we make apartments, we make houses, and things of our own scale. We make small things also, but again small up to our own scale, not too tiny things. Maybe the tiniest things we make, are what human beings made with their hands long ago. But modern science or the modern physics has been dealing with the tiniest of the objects, and on one hand, as I said, there are galaxies, there are stars, there are objects like that. So that is the macrocosm, the huge, big universe. And this one is the universe in the smallest, the universe in its tiniest of the dimensions. Now, there is a big difference here, which is what I wanted to highlight. And that is where there are some very interesting parallels between the ancient traditions and the modern science. Okay, what is it that I wanted to, allude to? For the biggest of the objects, the galaxies, the stars and planets and so on, there is nothing that you can do with them except observe them. Just see them, just learn about them, just see how they are and what they are doing, what are the basic laws, but there is nothing that you can influence such, huge mega objects. On the other hand, when you are observing the micro-universe, that is the universe in its smallest of the dimensions, then it gets extraordinarily sensitive. Sensitive in the sense that you have to be extremely careful in handling these objects so as not to disturb them while you are observing them. Your very act of observations can disturb this object. Your very, act of seeing them, measuring them, can, throw them from one state to totally different state. Galaxy, it doesn't care whether you look at the galaxy or you don't look at the galaxy. The star, it doesn't care. The sun will do its job, independently of you, so to say. However, when you observe a tiniest of the particles, such as, say, for example, a charged proton, you want to observe a proton, you want to measure it. How will you do that? See, normally we don't think how we observe. We just observe, we go on, we do our job, we move on. But it's very interesting. What is the process of observing the object? You see me, how the light up there, and that is made of particles or the waves, light waves, or the light particles which are called photons, they fall on me, and then they enter your eyes, and then your brain recognizes the image. This is how you see me. But the photon is so tiny, so small that it is not going to disturb me when it falls on me. And similarly, when you see it, it is not going to disturb, your eyes, because your eyes are capable of taking all that energy. However, if you are observing a proton or an electron, then what do you have to do? You have to shine a photon on that particle, small particle you have to throw, the photon, and the photon has to come back to your eye or your measuring instrument, and only then you are going to be able to measure it, where its position is. But what happens is when you throw in the photon, then the very act of collision of the photon with the electron, they are both, very equal in energies or in masses or so on. And then what happens is the electron is immediately disturbed in its position. And then that disturbance in the position is what is called, the uncertainty principle in quantum theory. If you are trying to measure, its position, then some other quantities are not sufficiently strongly or accurately measurable. If you measure its momentum, its velocity, or certain other quantities, then its position is not so accurately defined. So, you get a very important hint here that the observer and the observed, they are not totally independent of each other. They affect each other. And that is where really the basic riddle of quantum gravity, so to say, appears. That is where the basic riddle of the quantum gravity arises. What shall I say? Because the quantum on one hand, okay, let me put it this way. You see, the universe has 4 fundamental forces, really, as we, say it. The one part is gravity. The gravitational force we all feel, and the universe in its very large, all these galaxies and so on that I was mentioning is governed by the gravity. Then there are electromagnetic forces. So electromagnetic forces is what is holding, so to say, the molecules or the proteins that we talk about, or the food stuff, or the buildings that we are making. It's the electromagnetic forces and the cohesion between the molecules that is governing this phenomena at this scale. However, there are forces within the very heart of the atoms. Atom has a nucleus, and outside the nucleus the electrons are circling. But in the nucleus there are what they say neutrons, and there are protons. So these protons are positively charged, but you know that when you bring 2 poles which are similar of a magnet, then they repulse each other, and the opposite poles, they attract each other. Now the protons are positively charged, and then what will happen is that they repulse each other. However, within the atom there are forces which are called strong and weak nuclear forces, and these are the forces which very strongly hold up the atomic nucleus. So these are the forces which govern the universe as we see it today. But the huge problem, and the problem that is of quantum gravity, is that the universe at large is governed by the force of gravity, which has a description, which has a mathematical formulae and so on, which are very different from the framework of the quantum theory. So the two are, not matching with each other, and this is the issue. This is the big problem of modern physics, so to say. And then, unless we solve the issue of the observer and the observed, that is, what is actually the interconnection between the two, in its entirety, as long as we do not understand that, there is very little hope that we may be able to solve the issue of, the gravity and quantum, describing them together in its entirety. And this is where, in fact, the Vedanta tradition, in some way, gives us certain very interesting and important insights. That is, describing the universe, the observer is very important, so to say, in the ancient traditions, or even in particular in Vedanta. What the observer sees, that is how he will make the pictures of the universe. But for the moment, let me just go on. Let us proceed. Well, there are symmetries in the universe, you see, at very smaller scales. Further, next one. This is yet another symmetry that you see in nature. Next one. So, the next one. When we observe the cosmos, you see, we have seen, for example, explosions in the universe. The massive stars. The stars, you see, are out there. And the stars, what they do is they give out, you see, the heat and the light. And that heat and light really comes from the nuclear combustion, the fusion process within the star. What happens is that the star is mainly made up of hydrogen. So the hydrogen atoms are coming together, they make helium. And when such a fusion process occurs, then certain amount of energy is released. And then helium atoms combine to make a higher weight element, and so on and so forth. And at some stage, then this fusion process stops when you have made, the highest weight element, which is the iron. Then what happens is the star is cooling down. Earlier it was very hot. But then it cools down when the nuclear, fuel is existed within the star. And then what happens is, just as you release the air from a balloon and the rubber contracts the balloon, similarly the force of gravity compresses the star hugely and enormously. So then, at the end point of such a contraction of the star, and you must have guessed what is contracting the star. It is the force of gravity. The mass that is there, of the star, then, brings, just like the balloon was contracting, similarly, the force of gravity, contracts the star entirely and fully, and at the end point of such a contraction, there is a massive explosion. Now, why the explosion happens? That is because the massive star has an iron core, and on that iron core, all the matter of the star is falling, and that is creating a big shock, what is called a shock wave. You can imagine it like this. You see, throw a pebble, from this much of height to the floor. Then, it will make an impact on the floor. But now think of a big stone. Take it to the roof of this building and throw it to the ground. When you throw a stone this big on the ground, then it will break, some tiles, and it will, create a lot of disturbance. Why? Because the more it falls, the more the impact, and the heavier the stone, then the more mass falls there, then it creates more disturbance. Now, going further, think of a big truck, or take your car, which is of course junk at the moment, at the top of say a 20-story building. Take it up there and throw the truck, from up there. And now you can imagine what a big impact, what a big shock will be there. Once the car falls from that height, then it will be, when it really impacts, it will be thrown into pieces really. And the pieces will go around, you see. And it can, they can go fly like bullets, really. So similarly, what is happening here is not just car, you see, or not just trucks, but thousands and thousands of tons of material. Thousands and thousands of tons of material is falling, not 10, 20, 30 stories from the top of that building, but that is falling freely under gravity for the entire radius of the star, which is thousands and thousands of kilometers. So such a huge mass falling from such a big distance on a solid iron floor. So that is what is creating, a huge explosion at the end of the day. And then that is creating this particular shock, which is, called a supernova. So I explained to you really how, the supernova is working. But for the moment, let us just go on. Next one. So, this kind of, huge explosion takes place. Next one. So the Chinese people had observed this kind of a supernova explosion arising from a massive star, and when it actually happened in 185 AD, then it was overshining the, almost entire of the night sky. All other objects were, less brighter than that particular object. But now, today, when we observe this one, then what happens is, this is called a Crab Nebula. We can still see the supernova explosion. Now the universe has, of course, the thousands and thousands and millions of the stars. Next one. And then this is the configuration. Have I completed about 40 minutes? Okay. Okay. Time has gone fast in the relativity, terminology, so to say. What I wanted to say, I'll try to conclude in next 5 minutes, so as to leave some time for some questions, is that the universe, in its entirety, is made up of galaxies. Next one. Each one of such galaxies will contain some 400 to 500 billions of these stars. And then our sun, even in one dot, on one arm, if you take one dot, that itself will contain thousands of the sun-like stars. So vast is the universe. Next one. Next one. Next one. So, in the universe, when you see it with, this kind of space telescope, as was the, Hubble Space Telescope, then each of these objects are galaxies. So you have, millions of such galaxies actually in the universe out there. So this is the entirety of the universe, and then the question then is, what governs this cosmos? It is the force of gravity. What governs the, atomic nucleus? That is the force of quantum. And then, how to unite the two? That is completely open problem. We really do not know. The modern science, despite its many successes, has not been able to resolve this particular profound puzzle. And as I alluded to you, it is the issue of observer versus the observed that is the crux of the matter. So there is a huge debate going on this particular issue nowadays, both amongst the astrophysicists, the particle physicists, and as they call particle astrophysicists. So let me just leave it at that, and let us leave the floor open to discussion or some comments. Thank you very much.
Hi, thank you for a really nice lecture on this. Historically, we've always seen people say that when you compare religion or like when you compare them with scientists, most good scientists are atheists, but growing up, maybe it's a common misconception, but I've always heard that a lot of scientists are atheists in the world in general.
Okay.
But having grown up in India, seeing the Janam Kunti, the way things are formed, there's always a scientific explanation behind this. Growing up, you just have to follow it because you're part of the society. Coming here, sending our kids to Chinmaya and other, Bal Vihar kind of, social things and educational stuff. It's really nice to see that you can really achieve that path towards finding out the truth or close enough. And my question based on that is, you have the Navagraha in Hinduism, and basically how do you compare that with what the world of science believes today? Because there's some planets which are missing, and it was very interesting when Pluto was discarded as not being a planet, so just curious to know your thought on that.
Yeah, well, the grahas, as you say, Navagrahas and so on, so, I talk of astronomy, cosmology, and on the top of that, you see, my surname is also Joshi. So, this question on, the influence of grahas is bound to arise. I was expecting some such question. But let me, tell you very clearly that as of, up to whatever extent the reach of modern science is concerned, no forces that we have observed so far scientifically do very clearly indicate to the direct influence as we imagine them to be, on human beings. So that is not scientifically, as of today, scientists are always open, you see. They may be atheist, as you sort of indicated, but, they also have a great faith. And what is their great faith? Their great faith is that the universe is governed by certain fundamental laws. So they believe in the nature and the fundamental symmetries and harmonies of nature. But they may not be believing, that, oh, there is some God sitting up there with, 4 hands and that kind of a thing. However, scientists also believe in the fundamental symmetries of the nature, but, talking of the astrology or the grahas and their influences on human being, I believe that was, one part of your question. So, even in our ancient, scriptures, if you see, for example, Yoga Vasishtha, if I recall correctly, I do not remember the exact verses, but when Rama is asking, Vasishtha ji, on the Prarabdha and Purushartha, between the two, what is really, the important force? Are we just, small toys subject to the, the destiny and the Prarabdha? Then Vasishtha clearly explains to him that it is the Purushartha, that is your duty. You have to follow that path. Whatever those influences may be there, may not be there. But independently of that, you have to follow. And I frankly do believe that even in advanced societies, sometimes you see there are some misconceptions to the extent that we become tools to people who are more interested in their personal benefits more than making good for you. So astrology sometimes goes into that domain, fortunately or unfortunately. So the best thing is, anyway, I would say from whatever science I have learnt, that by just wearing this or that object, or doing some small things here and there, you are not going to change, so to say, the flow into which you are going. So your real sort of effort is going to be your own action, your own purushartha. And in Vedanta also, that is, as far as I understand, very clearly told to you that it is your effort. You have to work on your mind. You have to go through the tools of listening, Shravana, Manana and Nididhyasana, and through that only you have to purify your antakaran and so on. So if you just say, oh, my grahas are like this, so that I can never learn Vedanta, so will that work? I mean, I'm sure Acharya ji or Swami ji or everybody will say, no, whatever be your grahas, you start learning, sit down. Isn't that right? So you can't make that excuse. I think I'm happy to make this point because you see, this question inevitably comes up, and in many societies and places, there is this influence and misconception. Yes.
Dr. Joshi, sorry. I was wondering what the connection was between your studies and the studies of modern astrophysics, or the unification of the gravitational nuclear force with Vedanta study.
Oh, thank you. You have given me the opportunity to say something on our own work, which I have not at all. Yeah, you see, we have studied the gravitational collapse of massive stars, 10, 20, 30 times the mass of the sun. And you see, in past many years, our work and research papers and the monographs and I have just written, a few years ago, an article in the magazine Scientific American. Many of you might have heard the name of Scientific American. So they displayed it as their, international cover story, translated in more than 18 languages. But the important point is, what we have predicted, and which the result that many international groups have by now also got the same result, is that a very massive star, either it will become a black hole, or it will become a fireball, becoming a very major explosion in the universe. So that is also called sometimes, such an explosion is also sometimes called a naked singularity. So earlier it was believed that the star will always become necessarily a black hole. But now this new possibility of fireball explosion, so that has attracted a huge amount of interest, and many research papers are now coming out, and our work is also being cited. So that is our contribution. Now, you see, about the unification part, you have a gravitational collapse of a very massive star, so the densities, the temperatures, the curvatures, everything is going very high, extraordinarily high. And then from that, very singular regime, there is explosion. Now in that kind of a regime, the laws of gravity and laws of the quantum must come together at extraordinarily high energies. So what we are claiming and what our studies are suggesting is that you have now an opportunity to observe the laws of quantum gravity in operation actually. So if you observe those regions, then you will be able to learn more about the laws of quantum gravity. so far only theories were being made, you see, force of gravity, quantum theory, how to bring them together. But now you have actual observational possibility. So that is what our own work is, alluding to. And this book, the story of collapsing stars that was mentioned, the Oxford book, which is written at general popular level, the intellectual person who wants to understand cosmos, that describes it in a relatively non-technical manner. Okay? Yeah? Yeah, please, yeah, please.
Yeah. Recently they found a particle called boson and they named it as God particle. Is there any relationship in why do they call it God particle? And what is boson that's named as God?
Yeah, this is very interesting. Let me be very frank. Scientists also play sometimes, small games, not big. Okay. You see why? See, a boson, what it does, a boson particle, what it does is it intermediates, it's an intermediary between the, to convey the forces between the particles. I have one particle here, say electron, another particle here, say proton. Now there is some force between the two. So that is supposed to be, being carried by the, massless particles which are called bosons. Now I mentioned to you these four fundamental forces of the universe. So when they wanted to make this so-called grand unified theories, they combined these first three forces. But they were missing, one, particle which would, communicate the force between, certain particles which are quark and leptons and gluons and so on. So then Peter Higgs had postulated that some such particles should be there which would have typical properties. Only if that particle existed, then, this grand unification will work. So it was proposed long ago, and they made the theory also, but the claim or the observation is that such a particle actually existed, and they called it God particle because it was so crucial, so important for the success of the, because they were thinking only if the God blesses, then only the theory will succeed. So then, they just named it as the, and then people get interested. But then, similar to what I was saying just some time ago, that in the name of astrology, so then, there are some writers or there are some authors, their interest is to make capital out of, write a book, how many copies it sells. You see, very simple. I tell you, there is no complication. So, but you see, at the root, there are some interesting facts. So we should try always to go deeper. They might have called it, anything. My name may be anything. But do I have those qualities? So it's something like that. But this particle is very fundamental, and that is why it was sort of metaphorically called a God particle.
Hari Om, sir.
Hi, hello.
So
Why you are sitting so far? There are places.
that's okay. ज्ञान हर जगह बट रहा है, कहीं से भी ले सकते हैं.
Very nice, very nice.
Question मेरा ये है sir. I don't know science, neither I know Vedas, but I have heard stories about our ancestors being in contact with God. And gods, what I think, they are not humans, they are some other entity which is much powerful than us. So we were once in contact with them. That's how Arjun won Brahmastra. That's how Arjun did transgender and turned into Brihanala for 1 year at will. So we were in contact with them. Today, if we try to get in contact with any other entity other than Earth, we have to go spiritual because our body cannot take us there. Because body can only live 100 years, and to get there, you need light years and light years to get there. So, knowing all this fact, what scientists are doing to explore the spirituality and not the bodily or observing the planet, but actually being there. So is there any initiative going on to do it spiritually, because body cannot take you there?
Thank you. Yes, very nice question. आधा हिंदी में आपको जवाब देंगे? Well, so you are saying that you are not in contact with God? Only the ancients were in contact with God. Even you are, or you can be in contact with God. And it doesn't have to be so far. You don't have to go light years. This just reminds me, you see, of my meeting with somebody, some very wise person in the past. So I was going to USA at that time, to spend a few years here. So he told me that, look, people can go 10,000 miles to USA, making all those big journeys, taking so many efforts, visas, green cards, whatnot. And then, they do that, but they cannot go 5, fingers deeper into their heart. You see, they can do all this, but they can't, go at least, 5 inches or 5 fingers within, themselves. So, you don't have to go light years. As Acharya ji will explain to you, you can meet him later. I have to go away. Acharya ji, Swami ji, many others. So the important point is, you see, it's not that they were in contact and we are in some miserable state, and you see, those were the good days, and you see now we are all, stuck with cell phones and, computer games. And, how sad, I mean, you see. They didn't have, by the way, computer games, I presume, in those days. So anyway, coming to your, point, see, scientists are interested in, figuring out the laws of universe. They are open, by and large, though some may be, adamant also. But that happens everywhere, you see. I mean, even within our family, your brothers, sisters, some may be very nice. Some may be adamant, right? Friends. So, you see, they are very open to such efforts, but still we have a long way to go, you see. I'll just give you an example. I think our time is, getting up. But, I was talking about stars and all that. So, you see, light is traveling, in 1 second, some 1 lakh and, 187 thousands of miles per second. But still the nearest of the star is even nearest of the star, light, will take 4 years to go. So, you see, our technological capabilities as of today are very, very limited. Maybe if we figure out the quantum gravity, then we will have what is called space-time topology. We can make transitions, you see, go from one region of the space to the other region of the space. But science has a long way to go. Scientists are definitely trying. We are all working hard, you see. So be assured. If you find something, we will let you know. Okay, thank you.
Hari Om, thank you very much, Dr. Joshi. It's wonderful, very nice. I hear it twice and it was so nice. So, one thing I wanted to touch on was this fact that You know, physics and science does not take you away from God. In fact, it brings you closer, I would say. Because I know, but I'm also a quantum physicist, so I know that in quantum mechanics itself, when you try to probe something and you use your intellect to probe something that is higher, that transcends the intellect, you cannot get there. It disturbs the very thing that you try to probe. And so that's what he talked about also. And so the point is that, you know, if you again take another look, another thing is that when you try to look at something further and further, how do you know how far is far enough? Huh? You've got radio telescopes and this and that to look at things very far off. You've got microscopes that can go further and further. How do you know there's something more, there's something not more than that? Huh? Only the intellect can only go up to a certain point. And to the extent that you can think, you can figure out and make instruments and then draw some conclusions. But otherwise,